This is gonna be a long one. I will be doing in this video a VAP control for a 4-arm intersection, and it will have stages of these, and each stage can be demanded or skipped. So if there is no demand, it goes to the next one. If there is no demand for that either, it goes to the next one and back. What we have is we have a major east-west movement. So this is stage 1. Stage 2 are these ones together, like that. Like that. And with that one. And stage 3 are basically these left turns. And again, so starting at stage 1, we go to stage 2 if there is a demand. We go to stage 3 then if there is a demand, but stage 2 can be skipped. And also, if there is no demand after stage 2 for stage 3, it can be skipped and we go back to stage 1. Stage 1 is our main stage, we always go back to that. So what we need to do is first we create a signal controller for VAP. I just loaded the files in. I will be using as a template the previous PUA file from the previous video. We will amend it, and I have an empty VISVAP. So where to start? Let's start with the PUA file. So I'm going to take it very simple. I'm going to use one signal group for basically all the signal groups in a stage. So a signal group A will be 1, so that we represent all signal groups basically. So like I'm going to use the same for these two, so they will have the same signal head. So in this way, in this case, I will have 3. So A is basically stage 1, B is stage 2, C is stage 3. Now we need to define the stages. So previously we had 2 in the previous video. We will have 3. So in stage 1, A is green, B and C is red. So A is green, B and C is red. Stage 2, B is green, A and C is red. And in stage 3, C is green and A and B is red, or are red. Because basically we have stage 1, we just use one signal group to make things simple. You can do it in your models as well. It keeps things simple. If you don't need to use, like, if it's not a very strange shaped intersection where you need to assume like different intergreen times and stuff. So let's say, you know, these arms are not back here or something, the stop line like that. Okay. And stage 3. So we have this set up. So again, stage 1, A is green, B and C are red. B is green, A and C are red, and so on. Starting phase or stage, sorry, stage 1. And now again, in this model, I won't be using an intergreen matrix because I just use a stage control and I want to keep things simple, and I will include the intergreen time here in the interstage and also the minimum green time I will include. That's why it is 12 seconds long. explained it in the previous video. Please check that out in more detail. Basically what happens, we have a 6-second intergreen and we assume at least 6 seconds. So the interstage will be, so as long as the interstage is on, it will deal with the intergreen and the minimum green. So 6 second plus 6 second will be 12, and 6 second then is the intergreen, and the other 6 second is the minimum green time, because once we give a signal at green, we can't take it away in normal intersections less than less than 5 seconds usually, and in the UK it's 6 or even 7. An arrow is usually around 4 seconds. So I just stick with 6. So that's why it's 12. It is 6 for the intergreen and 6 for the minimum. Okay, from stage to stage from 1 to 2. So from 1 to 2, we go from stage 1 to stage 2. We need to add a lot of interstages in this one, because from stage 1 we can go to stage 2, or if there is no demand for stage 2, we go from stage 1 to stage 3. However, if you are in stage 2 and if there is no demand for stage 3, we go all the way, jump to stage 1. So we will need one from 1 to 2, 2 to 3, 3 to 1, and from 1 to 3, and 2 to 1. Okay, so let's do 1 to 2. So when 1, in 1 A is green, in 2 B is green. So I think, so A, I use -127, that is a code by PTV set. You need to use this if you want, if this signal group is already green. So this is the start of the green time, the second column, and the third column is the start of the red time. So for A, for the signal group that is already green, obviously you can't put anything here. That's why you say -127. So it knows that it is already green. The start of the red is 0. So once the insert stage start, at the 0 moment, A will go red. B, start of green is 6, start of red. It is 127 because if it is already, so if I switch it to green, then there is no, this is not applicable, as this one was not applicable here. So here it is 127. Basically, you just need to use this setup and just change these two numbers. Use this when it is going to red, and use this when it is going to green. And here you just add the intergreen time basically. Okay, so this is done. We didn't need to change it. Then we go from 2 to 3. So in 2, B is green. In 3, C is green. So that means we need to make B red, because in stage 3 that is red. So we just use -127 and 0. A, that is not correct, so we put C there. C becomes green. So 6, because it's 6 seconds for the intergreen, which means C will be green 6 seconds after B is red. And then we put the same 127 here. Now I'm going to copy this and create interstage number 3, where we go from 3 back to 1. So in 3, C is green, and in stage 1, A is green. So we put C, we switch C to red. and we switch A to green. Again, start of green is 1, 2, 7 because it is already green, and start of red is 0. For A, start of green is 6 because we want to wait 6 seconds before it turns green, so it gives vehicles enough time to clear the intersection, so there will be no accidents. And 127 shows that the start of red, because it's not applicable. Okay, now we can go from 1 to 2, 2 to 3, 3 to 1. We need to include interstages for the cases when there is no demand. So when we skip 2, so we go from 1 to 3. So let's do that. The number of empty rows doesn't matter. So you can have 1 or 2 or 3 or whatever. So from 1, and this is, so the interstage number is 4. We have 1, 2, 3. So this is number 4. We go from stage 1 to stage 3. So this happens when there is no demand for 2, but there is demand for 3. So we jump from 1 to 3. In 1, A is green. For 3, C is green. So we need to make A red. We need to switch that. So start of red is 0. Start of green is -127. And C, because in stage number 3, C is the green. A and B are red. So C goes red. Sorry, green. After 6 seconds, A is red. And again, 127, the start of red, because it is not applicable, so you need to use this special code. Let's do, if 3 needs to be skipped because there is no demand, we go from stage 2 back to stage 1. Interstage number 5. Oh, sorry, I did not copy. Stage 5, we go from 2 to 1. So if from 1 to go to 2, and there is no demand for 3, need to jump from 2 back to 1 to restart the cycle. So here in 2, B is green, in 1, A is green. So we need to switch B red, and we need to switch A green. And we use the same length for all to keep things simple. Okay, so let's have a look. So 1 to 2, 1 to 2, 2 to 3, 2 to 3, 3 to 1, 3 to 1, 1 to 3, 1 to 3, and 2 to 1. I think we covered everything. Let's have a look at the VISVAP. Okay. Let's do it a bit nicer. So there is a function called an interstage active. This is a question, basically. Let me just using this little icon is at a few rows. So if any interstage is active, we will go around. So here, let's check for stage active. If stage 1 is active, so this is our main. I just put this an interstage here, an interstage active, because what we will do is we just basically have a loop around, so it will run faster and simpler, and it will be cleaner. That if it is true, then it's not going to go and check all of these conditions, or sorry, yeah, conditions, but it will just go around. Okay, let me just delete that. So if stage 1 is active, is stage 1 here, these. If stage 1 is active, since we already checked, so we don't need to check for minimum green times, because we already included 6 seconds. So whenever the interstage is over, so whenever this is false, so it comes here, that will mean that the minimum green time has passed. So we don't check for that. What we check for is if we need to extend it, if there is enough demand for stage 1 to keep active. That is the first we do, and then we will check for demand on the others. So these are stage 1 movements. We place a detector here, somewhere in the end, a bit further up. So what we will do, we will check on this detector if vehicles follow each other closely. If vehicles follow each other closely, that means there is like a high demand. If the following time behind vehicles are great, that means there are big gaps between vehicles. That means the demand is low. So we can start thinking about checking the others. But if vehicles follow each other closely here, that means there is a huge demand probably. So we need to keep it open. However, we only need to open to a maximum green time, let's say a minute, because we need to make sure that this, if there is a demand on it, it can't be green forever. So after like a minute of green time on this, we will check demand on the others, and if there is a demand, we will switch. Okay, so let's place detector here, port number 1, signal controller 1, and another detector maybe here. Well, you can, let's do 2. In cases where you use like, when you use things like occupancy and stuff, you are fine to use the same port number. But when you check for following times, I think it is safer to just use a different port number. We just use all these settings basically default. The length of the detector don't matter that much. I think for these headway detectors, you want to keep it relatively short, maybe like 3 meters or something, or 2 meters or something like that. It doesn't matter to be so accurate, but maybe 2.5 meters or something like that is fine. The distance, upstream distance from the stop line, what we place the signal heads. It doesn't matter too much. Maybe keep like 20-30 meters. I think that's reasonable, but again, it depends on your headway, your situation. If you check for greater headway, and your interstages are longer, and your amber time is longer, then you can maybe move it further up. If it's shorter, you want to place it a bit shorter, so, oh sorry, closer. So let's just place it somewhere there, around 20 meters upstream. Yeah. Okay. So what we do, is we basically add a new condition here where we say, so for headway, we go to the detector group and we use headway. So headway in a second of detector since last detection. So basically checks the following time between each vehicle over the detector. So headway 1. Headway. So let's say gap, or just let's call it gap, and we will add that parameter. So gap, it's gonna be 3 seconds, let's say. If vehicles follow each other or the following time is less than 3 seconds, they usually drive quite close to each other. If it's more than 3 seconds, I think it's safe to say that the demand is not that great. They don't squeeze and they push each other that much. If it's greater than that. So if the headway is greater than gap, that means there is no demand. What we can do, you can put it here, and the expression is mainline demand. Mainline demand. Let me replace it like that. So if the following time is less than 3 seconds, there is mainline demand. So it's just basically a text name here, what you can replace here. Mainline demand. Mainline demand. So if there is mainline demand, then we don't do anything. But we also need to check for maximum green time. So max green mainline. Let's say 60 second. No, let's do 60 second for all. So max green 60 second. So what we do, mainline demand. So if there is mainline demand, or I think it makes no sense to replace. I will replace another one. I will replace another one. Or you can create a new row with Control Enter. Or we need to check the green time. So T green and the number. So here, if we open the signal controller, we create 3 signal groups. So this is A, B, C. Min green, I just put 5, but it's gonna at 4. Or let's put 4. It will run anyway for a given time. Red amber, let's put 2. Amber, let's put 3. I think that's fine. That is like that represents a good average. Let me just place the signal heads. So this is A. I just use the duplicate. Sorry, it's here. And we need to place it on the connector as well. Let's not forget. There. Or we can just move it a little bit. That. Let's just move this connector a bit closer to avoid any issues. All right. we need to put place a signal head on this one. This is C, and B or stage 2 will be the north-south. C. Okay. Now let's place on this one. Let's move these a little bit further up, so the 6-second intergreen time will be reasonable. So if the distance of the stop line from the middle is the same, I think it will be fine. Okay. CC. That's fine. We can tweak these later if needed. All right. This is C. This is B. B. All right. So if we go back here, so green time is 1 because this is the first. So signal group A is 1. 1. And we need to use brackets. Yeah. When we use operators like these, we need to use brackets. Okay, so let's check what do we say here. So headway is less than gap, or T green 1 is greater than max green. So let's just double check that and think about what we should say here. So we need to go, I want to go to the right. If there is no more demand or the max green expired. So if T green is greater, that's fine, and the gap is greater. So either one of these happen, we go here and we check for demand on the others. Or we can do it the other way around. Let's keep it like, no, let's do the other way around so we can have this. So headway, in that case it is smaller, yeah. So if the headway is less than the gap, so vehicles follow each other closely, or it is within max green time. So if that is true, we stay. So if the headway is less and the max green, if the max green, no, I'm going to do it the other way. I'm used to that more. I'm used to, sorry for changing it so much, but this is a good practice at least to hear or see what changes. So headway is greater than gap, so there is no demand on it. If there is no demand on it, we can go and check for other demands. Or there is still demand, so this is less, but this is true where the green time is already more than that. So in this case, we will keep going this way and check if there is a demand for stage 2. we need to place detectors to check for demand on these approaches. So I just place port number 3. Okay, so something to check here. So if vehicle is staying on this for this top line, the back will extend all the way back to the detector. But what you can do, you can just duplicate it and place it over that, a shorter one like that. Yeah. This can be also 3. Basically, if there is a demand on any of these, it will be called. The distance from the stop signal head doesn't matter that much. If the point is the vehicle should be on it, or a part of the vehicle should be over the detector. And again, the length. It can be a bit longer here, so it's fine. It doesn't matter that much. It can be longer, shorter a bit. Depends on your situation, how far you want to check, or what do you want to check. Probably better to keep them maybe a little bit shorter to make sure that vehicles actually arrive on it. So if it is like too long like this, a vehicle is driving and it will already sense that there is a demand, but we don't really want that. Yeah, it's fine. Let's go back here. So here we check for detectors occupancy time. So if occupancy time on detector number 3 is greater than, I don't know, 3 seconds, it's good to give a few seconds there for vehicles to arrive, because if it is too short, I think it's just better to let them wait a bit. So if occupancy on the detector number 3, or sorry, detector with port number 3, so these, there is a demand there, we go to stage 2. So what we do here, we add the statement, we move to interstage from 1 to 2. So if there is a demand for stage 2, so port number 3, here you put the port number for occupancy again. So port number 3, that detector has a port number 3. So that, and so that. And that is stage 2. Yeah. Then we go to that. And then we can join that and we will carry on down. So what happens in these cases? Let's come back. So if occupancy is smaller than 3 or equal, so that means there is no demand for stage 2. We need to check for stage 3. Okay. We need to place detectors here. Four. So we create this one. I just copy it. Just we have 4. So this means demand for stage 2. This is demand for stage 3. Because for stage 3, we use detectors with port number 4. In that case, we need to initiate an interstage from 1 to 3. So this is the way you can skip a stage. If there is no demand for it, you go to the next one. like that. And what happens if there is no demand for 3 either? Basically nothing. We just go out again. What happens if there is still demand for stage 1 and we are within max green? The same, go out again. Let me just put a empty row here, a few. So next one is stage 2 active. Yeah, let's do that. So what happens if stage 2 is active? We are here. We check for demand on stage 2, if it needs extension or not. So we need to place detectors a little bit upstream. Port number 5. Six. So again, when I check for headways, I prefer to use separate port number, because when the port number is the same, Vissim assumes that they are in parallel, and I think it's safer to just keep it like this. So in case there is a vehicle on this one and then another one on that one, that is not something I want to pick up. And I think it's better to just be safe and just do two separate one. So 5, 6, 7. Okay. So if stage 2 is active, we need to check. Basically, we need to do the same as we did here. So let me just remove this headway and start with T green. So if T green 2, so the green time on stage 2 signal groups is greater than the max green. So that means they're either way, regardless of there is demand or not, they will, if it's over, it needs to go out of stage 2, basically. That's what I want. But we need to consider cases where there is actual demand and we are within the max green time, so we haven't reached 60. So let's say we are at second, we are at green time 30. So it has been green for 30 seconds and there are vehicles still coming. So I still want to keep it open. So headway, it was 5, 6, and 7. So let's do 5 first. I need to use brackets. So if the following time on the detector is greater, so that means there is no demand on it. Or so we need to use another bracket and we need to check for all six, 7 detectors. So what I do, this max green is in an OR relationship with all of these. These are in an OR relationship with each other first. So if the gap is greater here or on here or on this detector, this will be one, true, or this one. So what I do, I think that's enough. So basically, again, if the green time is already over the max green, then we go, or one of these true. So there is no, so if there is dream, there is, we need to check for end here. We need to use an end operator, because if the headway is greater on that, and on that, and on that, so in this case, this will be 1. This will be true only if there is no demand on any of them, but I want to keep all open if there is a demand on any of these. I hope it makes sense. So AND means that this is true only if all are true. And if it is true, then I check if the green time has passed or not. So if we are here, basically, if we come here, that means there is no demand on any of these, and or the intergreen is greater. Sorry, the green time is greater. So that means I need to check for stage 3 demand. And if there is no stage 3 demand, I go back to stage 1. So I just copy paste this, because port number 4 is the detector on stage 3 approach. Stage 3 approach. If there is a demand on stage 3, I go to stage 3 and I put the interstage there, and we are in stage 2, so interstage 2 to 3. So I initiate the interstage, we go from 2 to 3. If the green time is greater than the max green, or there is no demand on all of the stage 2 approaches. Okay, sorry, this is not a condition. This is a statement. Yeah. So what happens if there is no demand on stage 3? We are in stage 2. There is no demand for stage 3. We need to jump all the way back to stage 1. So we create here another statement, and we put in interstage command, and we go from 2 to 1. You can use this line tool and go all the way to the end. So if you click there, then you hold Control and click to the end. It will do it. It didn't do it. It should do it. In some cases, it does it. So like you see, when it's conditioned, it does it. Anyway, what happens here? So if there is demand and the max green hasn't been reached, we can stay here and basically just stay in stage 2. What happens if we are in stage 3? We just basically need to check if stage 3 needs extending and within max green, and then just send it back to stage 1, either before or after. So we do the same check as there. We need to place detectors. So again, stage 3 is that one. Stage 3 is this one. We put a detector number 8 here, number 9. So let me just copy paste this. So T green 3, this means we check for the green time on signal group number 3, which are these ones. If these has been green for at least 60 seconds, or both of the detectors, so both of the approaches are not demand, so not busy, then we go here, which means there is no demand here, so we can go away from stage 3. So we need to send it back to stage 1. Stage 3 we are in, and we go to 1. Again, stage 3, we go back to stage 1. If there is demand, still demand, and we are still within the max screen time, so we haven't reached it, we stay there. And then we can come out. So as you see, this is a very simple control. I'm not sure that this will work, so we need to test it. Let me just save it, generate it. Okay. So just a note here, we haven't included anything in the logic that checks for end of queue. So if the queue is too long here and reaches this point, we haven't checked anything for that one yet. We will deal with that later, yeah? Let's just make sure that this works the way I want. Let's check. We loaded everything. Okay. Let's see what error comes up. Mainline demand. Okay, let me just check for that error. Mainline demand. Okay, it just warns me that we have added this expression, but we didn't use it. So I'm going to delete, and later we will add something here to make it nicer, and I can show how it works. Let's just do the checking first to see what. Oh, I need to generate it. So it seems that stage 1 and 3 works fine, but stage 2 never gets a green time. So let's maybe just a typo somewhere. So let's have a look. So if we are in stage 1, it seems this never gets, this never works, this never happens. Port number 3. Or maybe the problem is in the PUA file. So let's just see. Oh, I need to save it. Let's just check. So PUA interstage 1 to 2 goes from B, 2 to 3 B to C, 3 to 1 C to A, A to C. Okay, so that should be fine. So now what we can do is 1 to 2. Let's just run it again. A bit, let's just check for. Yeah, that's fine. Just vehicle inputs. Simulation speed. Let's just make it a bit slower so we can see what's going on. Okay, it doesn't work well. So what we can do is we can switch on debug mode. Okay. And put this side by side. So so it keeps going to the end. As you can see, so I need to click 10 times before, because the simulation resolution is 10. The VISVAP frequency is 1, so it happens, it gets run once in every second. I show you how to change that. Okay, so now what happened? Okay. Let's just wait until that is. So we are there. And now we need to go. So stage 1 active. It goes there. Occupancy. There is occupancy in it. But it maybe not for 3 seconds yet. Then it goes out because there is no demand on anything else. I just do it again. We here, we click through and still over. Another one. So now we are here. Still not true. We are back. And now it was true. It initiates the interstage. So we should go to interstage 2. Okay. We are in interstage 2. Oh. And it doesn't open that one. So probably what happens. Yes. So I made, I think, a mistake there. So stage 2 is this, and I assigned the wrong signal group. There you are. So let me just stop the debugging. I stop it. Now I just change these back to C. And this is C. So this should be B. Ah, yeah. Such a simple error. Okay, let me undo the debug mode that has a tendency to crash everything. Okay, and now it works. And so as you can see, it can skip phases, and now that should come. Let's increase the demand a little bit here to just see that extension. 800. No, you saw that kept it open, and the bus or HGV was very slow. So what you can do, or what we can do, we can increase that 3 second because it seems that trucks can have a good influence. So if we increase that to 4, and this is why it's good to keep parameters here, because you can only change, if you want to change it once. So you don't need to go here and do it one by one, because you have 4 there and there, but you would need to change it manual every single time. So that's okay. And let's increase that vehicle input even further. And again, there was a gap because that car went there. So as you can see, in this case, it is a bit hard to find where is the location. So you can move this further up here and keep it back at 3, because this way you can check. So it will keep it open even if that vehicle might go there, but if the demand is great, it kept it open again. So as you can see, it works fine. What we can do is, I said I will show how to add an end of queue detector. So what happens if one of the stage got very busy or can be very busy and block something back? So let's say the stage 3 is this. So let's say the end of the queue reaches back here, and we want to make sure that if that happens, we jump. We don't give stage 2, but we come all the way directly to stage 3. So I don't think it's a common way to do it. I mean, they do it in many cases, and it's common. Just if you do that, it can lead to problems. So you need to also take into account that if it happens very often, that stage 2 might get too busy. So it's probably only good in places where stage 2 is a very minor arm, like a pub access or something that can be skipped multiple times. Otherwise, there will be an issue. So that's going to be port 10. And we check if the queue reaches on this connector back. And we only check it on this case. We don't check the other arm. No, let's do it on the other arm. And I make some changes. So if the queue reaches back that connector, I will change the routings a bit, so most of the vehicle will come here. Yeah. So let's go to stage 1. So now what you need to do is you need to basically create an override there. So occupancy free, so that can happen. What I can do, I can just insert a row here and add an extra condition that even stage 1 and stage 2 can be cut early. So we are not going to check for any gaps or any mouse green, anything, regardless what is the demand on the other arm. But if there is a demand, if the queue comes back onto that point, we must shut everything and let this clear out. This can be a case when maybe, let's say, there is a railway crossing there, and it doesn't matter what happens here, but you must, if the queue is great on this one, you must let it go. Yeah. So stage 1, let's put here an occupancy. This is 10, detector port number 10, port number 10. We can put a bit larger value there, so maybe 5 seconds. If this, so let's just think this through. If occupancy is less than 5, then we go towards. If this is not true, we add the statement here. Interstage 1 to 3. So we basically jump like that. Okay, let me change the routings a bit here. Relative flow. It changes by the time. I am going to rewrite, and we will move everyone basically into here. So let's say from the 900 second, I zero everything out, and everyone will come here. Okay, and I change the input. I remove it back here to 500, reduce it, and this increases up to 1000. So let's see that after the 900, wherever we are, oh sorry, if we are in stage 1, okay, let's do the other ones as well, sorry. So stage 1 we did it there, let's do for stage 2 as well. So the same in stage 2, if vehicles have been there for 5 seconds at least, the interstage will be initiated immediately, like that. And we don't need to do it obviously for stage active 3, because we are already in that one. Okay. So let's wait until 900. Okay, so after 900, the routing will change significantly. Sorry about that. So Why is not extending it? There is some funny thing going on. Port number 2. Good. We did not add a condition here for port number 2. That's good that this test showed it. So what to correct it, we only check for headway on 1. So we need to create another gap there. So what we do, let's just think about what do we need. So either the gap on both, so I add another bracket, so this bracket and this encloses this whole section. These both headways will be together with an AND operator. So if the gap is greater on 1 and on 2, or the mux green, I think that's fine. So we are making sure that on if the headway, so if there is no demand on both, then we can leave the stage. If there is no demand on 1 and on 2, then we can leave. If there is demand on any of these, okay, yeah, that's fine. That should be fine. And VAP parameters, it's good that I misclick. So this is where you can set the frequency. So if you want to run it in every simulation resolution, you basically put 10 if your resolution is 10. At the moment it is 1, so it is only run once in a second. Okay, let me just compile it. Let me just restart it. Okay, let me run it to the 900 until we can see that one in operation. So now vehicles start to use that turn, but the demand is not great enough. So I need to put a little bit more cars there. Let me just do a bit that. Okay, we have arrived. All right. So now that will be extending up to 60 seconds. And once vehicles are there, so now it's cut back and going back to stage 3. Yeah. So you can use this tool basically to cut in front of everyone and all the conditions. And let me just show you a very quick one. So if you have a lot of stuff here and you want to just have something there, a short one, you basically copy that whole thing there. And you can say here that this is demand check, demand check, and it should work. Yeah. So if you have a lot of stuff going on there, You can just replace them with small expressions to keep things simple. Thanks for staying and watching it all the way to the end. I know it was a long one, but I wanted to show you basically the process. You can always just, if you're not interested in the explanation, you can just take it and amend the way you want. Just it is quite hard, I think, to change without understanding why I did what. So let me know in the comment section below if there is anything, any question or idea or recommendation or query or whatever. And please like and subscribe, that would help the channel a lot. Thanks for watching.